Today's lesson is about scatterplots and line of best fit, but before we do that, let's go over last night's homework. So you guys had 3 questions, question 6 through 8. So question number 6, that one, you basically just had to read that. So remember, it's broken up into quarters. We have the minimum all the way up to quartile 1. The median is a second quartile. Quartile 3 would be 75th percentile, and then all the way to the max would be 100. So what conclusion can we make? So the second quartile is 600. Now remember that these represent, so they're by hundreds. So this is actually 100, 200, 300, 400, 500, 600, 700, etc. So the second quartile is 400, so that didn't work. The mean, we cannot tell the mean. This doesn't tell us the mean. It tells us the median, but not the mean. So that one was meant to trick you, to help you to make sure you understand that the median in the middle is not the mean. That does not mean the same thing. The range would be from 100 to 900. The interquartile range would be 300 to 600. That's what they were trying to get you with. And then from 300 to 400, which would be right from Q1 to Q2, that is 25% of attendance. So the answer was number 4. Number 7, another one, you had to read the graph. For that one, the answer was 2. The medians were the same for police officers and musicians. And for number 8, that one you needed to use the data and pick which of the box and whisker plots was correct. And if you did that, again, if you found all your 5 points, actually for this one, you could have just found the min, the median, and the max, and you would clearly see that the answer is 2. And the reason for that is based on the median. Okay, so the median was 10. The only one that has a median of 10 is number 2. All right, so a scatter plot. This is a graph that relates bivariate data with points that are plotted but not joined. So basically, you're going to plot all the points, but you're not going to connect them with a line. Okay, so bivariate just means that there are 2 variables. So the main thing that we're going to be talking about is correlation. So the correlation is the relationship between 2 groups of data. So we have a couple different types of correlations. We have this is called a positive, this would be negative, and then this would be no correlation. So we'll talk about that in a minute, but that's where we're going with this. But the correlation, again, we have our x and y, so let's say time and distance. So this one we have, the more traffic there is, the more time it takes to drive to work. The older your car is, the less its value. So this would probably be, so the y would be price, and then the age of your car would be x. And then your shoe size and the weather today. So remember, on your x, you're usually going to have something having to do with time, and then the other quantity will be something else. All right, a trend line is a line on a splatterplot, a scatter plot that shows the correlation between 2 groups. And then the causation is a change in one quantity causes a change in the other. Okay? Change in one quantity causes a change in the other. So now what you have is an example of all the different types of correlation. So if we have a positive correlation, your slope would be positive. So you're going to start low and go high. Remember, we always read our graphs from left to right. If it's negative, it's going to start high and go low. If it's strong correlation, that would mean that your dots are very close together, and you can see that it makes the general line. Okay, that's a general line. Now, a weak positive relationship. That would be the points look like they're rising, but they're a little bit spread apart. And then if we have no correlation, see how the low correlation kind of slants, so it still is going in a general direction. This one has no slanting. It's just a big blob in the middle. Now the big thing that you have to understand is correlation is not the same thing as causation. Okay, so correlation is the data that we actually get the data from that. We take data and then we plot it on a graph, and then we talk about the correlation. Okay, so let's talk about correlation versus causation. So for each of the following bivariate data, so remember it has to, so if it's not bivariate, it would be univariate. Okay. So that would mean 1. So bi, that means 2, right? So there has to be 2 different quantities that we're talking about. Okay, so the sale of snow shovels and the amount of snowfall. So that would definitely be a positive correlation, and there is not a causal relationship. Okay, because maybe they already have snow shovels. So, you know, if it snows a lot, they might have snow shovels already. So because there's more snow does not necessarily mean that you're going to buy more snow shovels. A hat size and a math test, those have no correlation, and it is not a causal relationship. An outside temperature and the amount of fuel to heat a house. So that would definitely be a negative correlation, right? Because as the temperature goes down, the heat goes up. So if we want to talk about this, so the amount of sales for snow shovels, as that goes up, the amount of snowfall would probably be going up as well. So when they're opposite ways, it's going to be negative. Okay. So now the opposite when the outside temperature, the amount to fuel your house, that definitely is affected. So that's a definite cause and effect. So that is a causal relationship. So for that, it really matters on the type of data that you are talking about with the relationship. Okay, so now what we're going to do is we're going to actually look at a scatter plot. So all you do is you're going to create, so your time is always going to be your x, and your test scores are going to be y. So for sake of time, I am going to do this for you in advance. Okay, and here is what it should look like. Okay, so this is basically just plotting points, all right? So you're going to have your time on the bottom and then your test scores going up the top. So you're going to put all of your points on the line. And remember, when you draw your line of best fit, you're going to want to have the same amount of points on the bottom as you do on the top. So it kind of goes through 2 of the points, and then there's 3 or 4 on the bottom and 3 or 4 on the top. Also, you can do this using your calculator. So the same exact ways that you've done it before, but instead you're going to use the scatter plot. Okay. Okay, so I put this in my calculator. So again, remember to put stuff in your list, you just go to Stat and then Edit, so Enter. And then in L1, I put my time. And in L2, I put my test scores. So remember, your independent is usually going to be time, and then your test scores are going to be affected by the time, so that always goes in L2. So the next thing you're going to do is hit your second, so you get a stat plot. Okay. Now, last time I did this, we did box plots, so I'm going to go back into this and make sure it's on, and now I'm going to click, you can see that this has a bunch of dots on it, so that is a scatter plot. Now you want to make sure you click that, because now we can put our x in L1 and our y in L2, and then we are going to graph it. And it didn't show me, so I'm going to go to zoom, and I'm going to go to zoom stat, and now it will show me my scatter plot. So my scatter plot looks like this. Notice that if I trace, so this is at 20. So notice that these are not necessarily your x and y axis. It's just outside of the box. So notice how high up my actual graph is. That's because I'm already at 60 over here. So please make sure that you don't start at the bottom. This is just showing you the general idea that you have. So that's what that looks like. Now what we can do is we can describe our graph. So the conclusion we can make is the more you study, the higher the test. So it would be a positive correlation. And then, is there a causation? Yes, because an increase in study causes a higher test score. So this is a positive correlation and a causation. All right, so we're going to do a couple of multiple choice questions for our examples. So for this, we just want to know which graph represents the data. So literally all you're going to do is you're going to go and look. So on day 1, it should be at 9. So number 1 doesn't even have a 9 right there, so it's definitely not going to be number 1. Number 3, that one works. 2 goes with 3, 3 goes with 2. Okay, 4 goes with 6, and 4 has a 9, so that one won't be it. So go here, so 1 goes with 9, 2 goes with 3, 3 days for 2 hours, 4, 6, 5, 6, 6. Okay, so if you look, number 2, that one is definitely the answer because all the data points match up. So again, that's all you're doing. Okay, number 2, which situation describes a correlation that is not causal? Okay, so it has to be a correlation and it's causal. So the rooster, I know it's so hard to read these. That did not help. All right, so number 2 says the rooster crows and the sun rises. The rooster crows and the sun rises. So let's leave that one for a minute, but I'm leaning towards that already. The more miles driven, the more gallons needed. So that is definitely a correlation and causal. The more powerful the microwave, the faster food cooks. That's definitely causal. The faster the pace of a runner, the quicker the runner finishes. Okay, so definitely that is it. So basically the rooster doesn't make the sunrise. Hopefully you know that. And again, that's another one where if you did not see the word not, you might have picked one of these and you would have just guessed and picked one because they all sound right. All right, so number 3 and 4 are going to be homework. So go ahead and do those. We are going to do a little bit of Trendlines, line of best fit real quick. Okay, so first we're going to talk about the line of best fit. These go with a scatter plot. Obviously they aren't directly correlated with an exact line, but our line of best fit is a line that almost has all the lines directly on it, but aren't exact. Okay, so what we want to do is we want to know which equation would most clearly represent the line of best fit for the scatter plot below. So what I would do, if you don't know this off the top of your head, is I would put them in your calculators. So what I wanted to do is just show you guys how to take this out of this mode so we can graph real lines. It's going to be very important for the Regent because if you don't know how to fix your calculator, then that stinks. Now remember, you can always do second and then the plus sign. You can clear your memory. But if you don't want to do that every time, and see how this is highlighted, that means that it's ready for you to graph a different type of graph. So a scatter plot, a bar histogram, a box plot, something like that. So if I just press enter, now it's not highlighted anymore. So I pressed enter and then the down arrow. So again, if I press enter again, it highlights it. If I press enter, it doesn't. Okay, so now we're ready to graph. But if you look at your window, it's still going to be off. So if you do zoom and then go down to standard, that takes you back to the normal 10 by 10. Again, that's zoom standard, because before we were in zoom stat. So zoom stat takes you to the data. This one takes you back to the graph. So let's graph. Go to your y equals. And let's try the first one. So y is equal to x, and graph that. Now if you look, lucky for us, that literally looks exactly the same. It's going up in the same direction. It is generally going towards 0, 0. So that to me looks like it's going to be the correct answer. If you wanted to try them all out, so these two wouldn't be right because they have to go through here, and that is not the general direction of the line. And then this one is a negative slope, so this would be negative. Okay, and this is clearly positive. Okay, so a trend line and a line of best fit, those are two words that usually are used interchangeably, but really a trend line shows the correlation between two groups of data. The line of best fit is usually what we talk about, okay? And this is an actual equation of the trend line. So this is what we are going to focus on, and I'm going to show you how to do it in your calculator. So before I have you put it in, I'm going to show you, once we get our actual regression, you have to understand how to actually write it down. Okay. So this comes from data that has already been put in. Okay, so what I'm going to focus on first is how you would read this once you get this. So A is represented by the slope. Again, this is a linear regression. So linreg is what you're looking for. Okay, so the steps are right here. But again, I want to focus for a second on how you read that, and then we'll do an example. So once you do this, you're going to get, your calculator is going to look like this. So what you want to do is you are going to leave as many are shown unless it tells you to round. Normally it's going to tell you to round, but this one didn't. So what we're going to do is basically we're going to rewrite this equation, but for A we're going to put this decimal, and for B we're going to put that one. So literally your answer is just whatever is right here, 84185,493, slap an X on the end of it, and then plus 60.15041617. So that would be your linear regression. That would be the equation, your line of best fit. That's off your calculator screen. So let's do an example where we actually go through all of it. Okay, so for question number 1, we're just going to practice doing this. Now these take a really long time, so I'm only going to show you one of them, and then I'm going to give you one for homework. Okay. So here's what you do. You go to your stat. Pretty much when in doubt, when you're doing statistics, you're always going to put them into this. You're going to go to edit. I already have them in here, so remember to clear your last one, you're going to go up, press clear, and then enter, and it'll zip them all out of there. So again, all I did was my years. So time always goes in your L1, and then whatever is dependent on the time goes in your L2. So now what you're going to do is you are going to hit your stat button again, and go over to calc. So whenever you need information, you're always going to calculate. So edit gets you all of your information in, and then the calc gets you to calculate something. So the one variable statistics is what we did when we found like mean, median, mode, all those central tendencies. If we want to find a regression, and for algebra 2 you use more of these, but if we just go through these, so lin reg, you can see right here, ax plus b, that's a linear equation. If I wanted to do a quadratic, and it would tell me, then you would do quad reg. Okay, and then so down the line. Now if you look at number 8, this is also a linear regression, but the bx, that's not what we want. Remember, think of y equals mx plus b. So a is equal to m and b is just b. So again, what we're going to do is we're going to go to number 4, because that's linear regression. And notice that it literally says that in the direction, linear regression. It tells you what you want. So whenever you see that word, like underline it or do something so you know. Okay, now you're going to go over it and press enter. Comes up. And press enter again, and it gives you all your data. So this is literally all you need. Now my advice to you is, on the Regent, please write down what you get in your calculator. Okay, so So, you know, if you want to write mx plus b, I mean, literally you can just write what they have right here. So a is 1.08, and it doesn't round it. So if it's a nice terminating decimal like that, then just leave it like that. Okay, so then the last thing, you want to actually write down your equation. So don't leave it like this. That just gives you data. But, you know, if you make a mistake transcribing it, then that's better that you have it. So there is your linear regression. So if it says linear regression, you better write a line. So look, I didn't have to plot anything. Didn't have to do anything mathematically, you know, finding the slope and whatnot. So you can literally put that all into your graph, or all into your calculator, and do that, just like that. Okay, so number 2 has a part B, which we will go over tomorrow. That's just after you find the linear regression, you actually have to use it. So we'll talk about that tomorrow. But I would like you to do number 4, because this is almost identical. So again, this is going to be x, this will be y. So you're going to put this into your, so stat, edit, okay, enter all this, and then you're going to do stat, calc, lin reg, y equals ax plus b. Okay, so those are the steps you're going to do, so go ahead and try that. So just to recap, you are going to do numbers 3 and 4. Number 4, let me just check these pages. So this will be page 22, and this will be page 24. So that is your homework. Please try it in class.